A time series is a list of observations ordered successively over time. In a time series, observations are often recorded at evenly spaced intervals, such as daily, weekly, monthly, and so on. A time series analysis studies how a variable changes over time. Let's look at some real-world uses of time series. Here is an example of monthly count of passengers in international airline. Time series is also widely used in finance. Here is an example from finance. This data is daily closing price of major European stock indices from 1991 to 1998. In a business, the data is often associated with dates and time. For example, number of customer complaints per quarter, number of products manufactured in a month, and so on. In a time series, each observation is comprised of two parts: a point in time and the value of the observation at that time. In case of air passengers time series, we have a number of air passengers traveling in each month for a given year. We have a month as a time component and a number of air passengers traveled in that particular month as a time measurement. In R, there are many packages that deal with time series data. In this video, we will look at some of the features of TS package, which is a part of base R system. Let's jump over to the R Studio and play around with the time series data. When date and time data are imported into R, they will often default to a character string. This requires us to convert strings to dates. Here is a date column. However, as you can see, these dates are character strings. We have to convert those into date-time object so that R can recognize these characters as dates and not as characters. So we will use the as.date function. We will pass on the character vector to as.date function, and after I execute this, it should generate the output as date-time object. If we check the class of the object dates, we get a date class. This is a very simple stuff because by default as.date function uses standard YYYY-mm-dd format, that is year, month, and date format. And we have the dates object exactly in the same format. But what if we have different date format than a standard one? Have a look at this string, which has / separating the dates, months, and years. In order to deal with this type of format, we will use format argument in as.date function and use one of the different types of conversion specifications to convert the character string into date-time object. The conversion specification that you will use must match to the structure of the character string you want to convert into date. The character string in our example starts with the year value, then month, and then day value, and each value is separated by a / operator. So the conversion specification must also follow the same structure. So after I execute as.date function, you can see the time date 1 is converted into a date class. I'm not going to go deep in this topic, but if you are interested in learning more on different types of conversion specifications, type in the help documentation of strip time function, and this is a date time conversion function. If you go to the help page and scroll it down, you will find there are different types of conversion specifications that you can use. Okay, now coming back to our main topic, we will now use a TS function from the TS package to manipulate the time series object. So let's first create a simulated time series data. Here is a time object called opening share price of a company. We will generate 12 observations starting from the first month of the year 2022. The frequency is 12 because we want to generate 12 observations in a given year. So if I print this object in a console, you can see that we got the monthly opening share price of this company for the year 2022. Also note that the object type is TS, which is a special class of a time series object. If you are using a TS package, then all the time objects belong to the TS class. This class is created in R to make it convenient to work with time series data. In a similar manner, let's also generate the closing share price data. And finally, we will bind these two vectors together to create a multivariate time series data. And here we have it. We got our time series. Let's perform some data wrangling operations on this data. In TS package, there are some convenience functions that make working with time series data much easier. We will look at some of those functions. Starting with the Windows function. This Windows function is a quick and easy way to obtain a slice of a time series object. For example, have a look at the share price data again. Let's assume that we wanted a data from the first quarter of financial year. We can filter out the data using Windows function. In India, financial year starts from the 1st of April. So the first quarter is from 1st of April to 30th of June. We will have to give the start time and the end time of a period. The start will be the April 2022. So when you write the start, the first value must be of the year, followed by month and day, and so on. Similarly, we will write the end date, and when we print it, we should get the observations from the first quarter. Let's look at some other useful functions. The start function returns the start date of the TS object. End function gives the end date, and the frequency returns the frequency of a given time series. The best part of TS object is that when you have a multivariate time series, you can use a plot function and R will automatically generate the multiple charts for each time series variable. Here we have two separate plots, one for the opening share price and another one for the closing share price. We have come to the end of the video. Time series is a vast subject in itself. We have just scratched the surface. I hope that these functions should help you to get started with the time series analysis. Thanks for watching till end. I will speak to you in the next video.